Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Okay, so reoccurring decimals can be the last section in sequence and series in some of the books. Okay, and a reoccurring decimal, you will always know it by the dot over the number. Okay, you place a dot over the numbers that reoccur. So the first point I have there, reoccurring decimals can be written as a sum to infinity of a geometric series or sequence. That's why they're in this chapter, where the common ratio or is less than 1. These decimals can be expressed using dot notation. A dot is placed over the first and last figures which repeat. So when you see a number like 0.3 with the dot on top, that is actually 0.33333, which is the fraction a third. 0.25 means that both the 2 and the 5 repeat. So 0.252525. And again, when we work it out, you would get 25 over 99. And you can work out any of these. If I don't have them as examples, work them out and see if you can get the fraction. And then 1.1.85. Okay, so I wanted to particularly draw your attention to this one, because in fact, in this one, all three repeat. It's 1.185, 185, 185. It's just using dot notation. You place the dot on the first and the last figure. Okay, that repeat. So if I had something like 1.12345, for example, and a dot here and here, they would all repeat. And so on and so forth. Okay, so this section is going to look at how do we take a reoccurring fraction, use the sum to infinity of a geometric sequence, because obviously these reoccur forever. That's why it's an infinite geometric sequence, and get the fraction equivalent of them. Okay, so I'm going to do this one as an example, and then I'll give a few to you to try. Okay, so write the reoccurring decimal 0.23 as a fraction in the form a over b, where a and b are elements of n. Okay, so I always started by writing out the reoccurring decimal. Okay, so it's equal to 0.23, 23, 23, 23, and so on and so forth. Okay, so let's then break it up some more. So it's 0.23 plus 0.0023. Actually, let me color code it. Okay. Plus 0. So to get at the green ones, I need 1, 2, 3, 4 zeros. 1, 2, 3, 4, 2, 3. Let's change to another color. To get at the two orange ones at the end, I'll need 2, 4, 6 leading zeros to get to describe them. 1, 2, 3, 4, 5, 6, 2, 3, and so on. Okay, so if I write them then as fractions, that's 23 over 100. This one is 23 over 10,000. Okay, so what you do is you count the number of digits here, and that's the number of zeros at the bottom as such. And then green next, green is gone on me. Plus 23 over 1, 2, 3, 4, 5, 6. And then of course 23 over 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's how it works. If there's two places over after the decimal point, they're 100ths. If there's 4 digits, they're 10,000s. If there's 6 digits, there's 6 zeros, and then there'd be 8 here. Okay, so I hope that makes sense. Why did I do that? Well, I did that so that I can get my first term, a, being 23 over 100. Okay, because remember I have to write them as the sum of an infinite geometric sequence. So I'm using this formula here. S to infinity is equal to A over 1 minus R. So my first term, A, is 23 over 100. My R is T2 over T1, okay, as normal, or T3 over T2, which would be 23 over 10,000 over 23 over 100, okay? And of course, you can use divide by for that particular one there if you find it hard to put into your calculator, but you'll get 1 over 100. Okay, so that's your OR. You then put it into your sum to infinity formula. So I have 23 over 100 over 1 minus 1 over 100. Okay, now you can put that all into your calculator all in one go. Okay, and of course I put it into my calculator wrong, so I'm going to show you now how I will put it into my calculator. So just put it in there now and see, can you get it in? And your answer is, yeah, I got it right this time, 23 over 99. Okay, so it just depends on because you have multiple lines, it depends on how your calculator reads it. So you just have to be careful when you're putting a fraction like that into the calculator, that your calculator is definitely reading it as, and you see I'm making this one bigger, 1 over 100, okay? And so the first time I put it in, I must have put it in as 23 over 100 over 1 minus 100. Okay, and it's the order that you hit the fraction button in. Okay, so just be careful. It bothers some people, it doesn't bother others. Okay, the easiest way of putting this into your calculator is to go 23 over 100 divided by bracket 1 minus 1 over 100. Okay, and then you eliminate your calculator ever making that mistake. So I tend to always do this to figure out if I've made a mistake putting it in as a fraction button. Okay, so that's how you do it on your calculator. Of course, we could have worked it out using fractions. So it'd be 23 over 100 over 1 minus 100 is 99 over 100. Okay, this is for anybody who wants to improve their fraction knowledge. And then how do you divide fractions? You invert the bottom one and multiply. Okay, so you turn this one upside down, 100 over 99, and you multiply. Okay, that's how you would have been taught to teach or to do fractions. And they cancel. And that's where you get the 23 over 99. Okay, so therefore, the sum to infinity is equal to 23 over 99. 0.23 as a reoccurring decimal, and as a fraction is 23 over 99.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.